now the Euclid book Elements and actually talk about we call that common notions, or at least he called that common notions. That means it's a postulate, it's a axiom. This means you don't need to prove it. It's something everybody agree on. So he came out, there's two there. Now if we write in terms, if the words actually a little bit hard to kind of a bit convoluted, but in terms of algebra, it's pretty simple. It just said if A is equal to B, then A plus C equal to B plus C. And if or A minus C equal to B minus C. So that's actually the essence of algebra, is that algebra dealing with how to move terms from one side equation to the other. So for example, if we're trying to solve this, equal plus 7 equals to, let's say that we got 5. And so we have to move 7 and 3 to the other side of the equation. Now, how do we do that? We know there are three things we can do. We can add same thing, or we can minus the same thing. Now, multiplication basically just addition. Division is basically subtraction. So we can also, if we have an equation, we can also multiply the same thing on both sides, or divide by the same thing on both sides. So that's pretty much what we do in algebra. What in essence algebra is, doesn't matter how complicated the problem or equation is, we're all dealing with how to move numbers to the other side of the equal sign. That's the equal sign here. Mostly we can move from left to right, and sometimes we move from right to left. It really comes down to what are we trying to do. Now here, for this equation, we're trying to figure out what x is. So therefore, you can see that on the left-hand side equation, just have x. Everything else goes to the right. So therefore, to move 7 over, we actually minus 7 on both sides. We know we can do that because we have that. This is what we can agree on. So we got 3x equals to -2. Once we have 3x equal -2, then we divide by 3. So that's how we move 3 over. That cancel. We got x equal to -2/3. So that's what we got. That's what we mean by solving. You can see that basically just by moving numbers from one side of equal sign and to the other side. Okay, are we good here?
Yeah.
All right, so now we get into quadratic equations. So quadratic equations, the simplest one is actually this: x squared is equal to something. Let's say x squared to 4. And now, in order to solve that, we have to using a very important property because zero product property, which says that if A times B is 0, then we have either A equal to 0, or B is 0, or both equal to 0. Okay, so let's see how we use that to here. And also, before we can do that, we also have to use an identity, which is this: A squared minus B squared equals to A plus B times A minus B. So we're going to use that. This is called difference of squares. Now, this is a very important identity. Okay, so first of all, we're going to move 4 over. Now, to do that, -4 on both sides. Then we got x squared minus 4 equal to 0. but we know x 4 is just 2 squared. Then we got x plus 2, then x minus 2. And we know this, given this initial equation. So this is actually original equation. We came up with equivalent. And this has to be 0. Now, how do we, what kind of value that, or x value, to make the equation true? Well, we know there's two situations. One is x plus 2 is equal to 0, and that gives us x equal to -2. And we can check if we plug in x equal to -2 here, the left-hand side is 4, right-hand is 4. So that works. That means that's a solution for the original equation. The other one is x minus 2 equal to 0, and that will give us x is 2. So now you can see that we started with a quadratic equation, something new to us. We made that into something we know how to do it, like turn that into 2 linear equations, and that we know how to do it. So that's the simple things this is actually pretty simple quadratic equations. And the reason we call quadratic is because of the x squared term, that term. And x squared basically is the area of a square, which each side have length and x. And for the square, we got 4 sides. So that's why it's called quadratic equation. Okay, are we good here? All right, now I have that. So let's try a couple. Now, if x squared is equal to 9, what will be our x?
Three.
There is 2. It's always 3 or -3. Okay.
Oh, yeah.
Well, how do we do that? We got x squared minus 9 equal to 0, and it's x squared minus 3 squared, and that is x plus 3 and x minus 3. That equal to 0, so we know either x plus 3 equal to 0 or x minus 3 equal to 0. So therefore, this gave us x equal to -3, and this gave us x equal to 3. So we got that. Good. Okay. And for this, we actually can generalizing it. So we can have a formula for this. To generalize it, we can say, okay, x squared is equal to a number. And in this case, c is a great positive number. And so therefore, we can write it as x squared minus c equals to 0. And we know we can change the c into square root c squared. And that will give us x plus square root c and x minus square root c. And to make that to 0, we either have x plus square root c equal to 0, and that gives us x equal to negative square root c, or x minus square root c equal to 0, and that gives us x equal to square root c. So therefore, we actually can make a generalization. If we have this the case, then our x is either minus square root c or square root c. Now, in mathematics, we can combine them, right, as plus minus square root c. So that's where you see that plus minus sign. It means it can be positive square root c or negative square root c. Good? Very good. So now we got our formula. Is that if we got this, then x will be plus minus square root c. Now, if we call x equal to, say, 16, then x will be plus minus square root 16. That gives us plus minus 4. Or if x squared is, say, 7, then x is plus minus square root 7. in this case, this is with something called irrational number. We cannot, if you want to write the decimal, it will be a infinite digit, but and non-repeating. Okay, let's see. We give this one x squared equals to 13. What will be our solution here?
It'll be negative 3.61 or positive 3.61.
Well, actually, what we got here is plus minus square root of 13. Good.
Yeah.
And we leave like that. Okay. We don't turn that into the decimal unless they that's what they require. But this is the exact solution. So we want to keep that.
Oh, okay.
Good. Yeah.
Yeah.
Very good. So now this is a pretty simple one. Now we get a little bit harder. What happens if we got, say, x squared plus 3x plus 2 equal to 0? And this is something we got about factorization or factoring this to solving it. Well, how do we factor in this? This comes down to is if we have two if we have something like this, x plus a times x plus b. Well, let's use p and q, separate that. Then by what we know, if we do the FOIL, we know this x times x squared, then plus x times q, xq, then plus p times x, then times pq. So now we got x squared plus p plus q, x, and plus pq. Now, so that means if we're going to turn this into something like this, and that's what we're trying to do, then this two number multiply should give us this. And this two number add should give us this. Good?
Yeah.
So how do we do that? Well, let's just try it. We know those two number multiply should give us 2. So how many choices we got? We actually have either 1 or 2 or -1, -2. So 1 plus 2 is 3. So we know that work. -1 plus -2 doesn't work. So therefore, we can rewrite this as x plus 1 times x plus 2, that equal to 0. Therefore, we know x has to be either x plus 1 equal to 0 based on our zero product property, or x plus 2 equal to 0. So therefore, we got x equal to -1 or x equal to -2. So that's how we find the solutions for this equation. Good?
Yeah.
And we can actually try it to confirm that is we're going to plug in our answer. So that's what we call that verification. So we got -1 squared plus 3 times -1 plus 2. That gave us 1 minus 3 plus 2. That's 0. Good. This is a solution. Then we can try x minus 2. So we got -2 squared plus 3, -2 plus 2. This is 4, this is 6, this is 2, and that is also 0. So left equal to right, so we know this is also a solution. Good?
Yeah.
Okay, let's try a couple more. X squared plus, say, 5x and plus 6 equal to 0. Now, this one we can either break down to 1/6 but 1 plus 6 is 7, so it doesn't work. Or we can break it down to 2 and 3. Then 2 times 3 is 6, 2 plus 3 is 5. So we know we can change to that. So we can make that into x plus 2, then x plus 3 equal to 0. So therefore, x plus 2 could be 0, and that gives us x equal -2. And x plus 3 can be 0, that gives us x equal to -3. So we got those two answers here. So this is called solving quadratic equations by factoring. Okay. All right, I'll give you a couple to try. So x squared plus, say, 4x plus 3 equal to 0. So what is our solution?
I got x equals -1 and x equals -3.
Very good. Good job. Okay. Say x squared minus 5x and plus 6 equal to 0.
Dr. Peng, I have a question.
Yep.
So when you factor 6, you get 2 and 3. And when you add 2 and 3, you get 5. So would that 5 be the same as -5, or would it be just 5?
That'll be 5. So in this case, you turn that into -2 times -3. Negative times negative is positive. -2 plus -3 is -5. So that's how you got that. So
Oh,
break down to x minus 2 and -3. Good?
yeah,
Yeah. So then x will be 2 or x equal to 3, right?
yeah.
Very good. Okay, so let's try x squared minus, say, 3x plus 2. And so what you got?
I got x equals 1 and x equals 2.
Very good. So those, you can see that we basically just add, we break this number, then we add it and make it the third middle number. And sometimes we actually have to do subtraction. For example, x squared minus 2x plus minus 3, well, it's 2x minus 3. So in this case, we break that into 3 times -1. -1 times 3 is -3. So we got that part right. Then 3 add -1 is 2. So we got that one right too. So therefore we got x plus 3 and x minus 1 equal to 0. Then we get x equal -3 and x equal to 1. Good?
Yeah, but I have a question.
Yeah.
So x has two values, 1 and 2, but it's the same x. How can x have two values?
Well, we're basically saying we have two solutions to this equation.
Oh,
Yeah.
okay.
Yeah, it's not that you have the both. It's just like one solution will be this, another solution will be that. Good?
Yeah.
Yeah. Yeah, another way you can think of it is basically saying x is 1 or -3. Good? And
Yeah.
it can be confusing because when we're talking about solutions, we say there are two solutions, x equal to 1 and x equal to -3. But what do we really means that is x could be 1 or could be -3. Good?
Yeah.
And which one is uh, the real answer? That depends on the situation. Okay, like if you're trying to solve, like say, a geometry problem or physical problem, then typically you cannot have a negative number. So in that case, then x will be 1. Good.
Yeah.
Very good question. Okay, let's try x squared minus 4x minus 12.
I got x equals -6 and x equals 2.
Very good. So we basically break them to -6 and 2, right? So that means we got x minus 6 and x plus 2. And therefore, we could have x equal to 6 or x equal to -2, right?
But I got -6 and 2.
-6, well, actually, it should be this. Because -6 plus 2 will give me -4.
Oh, it was a -4x. I put a positive 4x.
Right. If positive 4x, then you are correct. But here we got -4.
Yeah.
Yeah, very good. Let's see. We're going to have x squared plus 5x minus 36 equal to 0.
I got x equals -9 and x equals 4.
Okay. Yeah, so basically we're doing 9 minus 4, right?
Yeah.
That's why I got -9 and positive 4. Very good. Good job. So this is something we called factorization. We factor them and then we just basically solve two linear equations. And sometimes we'll get a little bit more complicated. If the first one is just, we call the leading coefficient is 1, it's pretty straightforward. We just break this number, third number, and then if we can add them together, give us the middle number, then we know we can break it. And sometimes our first is not 1. It could be, say, 2x squared plus 3x plus 1 equal to 0. Then how do we solve that? And this has to do with something we call cross multiplication. So this actually come down to is if we have function like this, ax plus b times cx plus d. So that's basically we want to break that into. Now, what can we see that is by FOIL, we got this. We got acx squared plus that, which is ax times d, then plus b times c and x, and plus b times d. And we can rewrite that as acx squared and plus ad plus bc x and plus bd. So what we mean by that is if we can break this into a and c, that a times c will be 2. So we break 2 into 2 factors, a and c. And we breaking that into also 2 factors, which is b and d. And now, So AC has to equal to, you can see that AC has equal to 2 in this case. Then BD, this 2 multiply has equal to 1. And then A times D, that's cross multiplication, right? Which is that cross. And plus B times C should give us in the middle. So that's where we come with this this technique to break that into AX plus B times CX plus D. Okay, and so let's see how we do that. Well, the first one, we can break that into 2 and 1. 2 and 1. This is a pretty easy. It's 1 and 1 times 1. That's what we can break. Then we'll see 2 times 1 is 1. 1 times 1 is, sorry, 2 times 1 is 2. And 1 times 1 is 1. 1 plus 2 is 3. So now we know we can break that into 2x plus 1 times x plus 1. Now, if we're not quite sure, we can always expand it, basically work backwards. You can see that 2x times that is 2x squared. This times that plus 2x, and that is 1x, and then 1 times 1, 1. So that is indeed 2x squared plus 3x plus 1. So that means this is going to equal to 2x plus 1 times x plus 1. And we also know that this is equal to 0, so this has to be 0. Then two situations or scenarios, 2x plus 1 equal to 0, and that will give us x is half. And or can x plus 1 is 0, that will give us x equal to -1. So we got those two solutions there. Yep. We good?
Yeah.
Okay, I'm going to show you a couple more. So we can use the same thing here, but in this case is a negative x, that. So we got 2, 1, and 1, 1. And but 2 times 1 plus 1 times 1 is 3, not -3. Well, we can change this to -1 times -1. Negative times negative is positive, so still 1. Then 2 times -1 is -2. This time -1 is -1. They add together, -3. So that works. So basically, we change this into 2x minus 1 times x minus 1 equal to 0. So therefore, 2x minus 1 equal to 0. That will give us x is half. Then x minus 1 equal to 0. That will give us x equal to 1. Good?
Yeah.
Okay. So now I'll give you a problem to try this. Okay. Now we have 3x squared plus 5x plus 2 equal to 0, and see what you got. Hello, Matthew. Hello, Matthew.
Can you hear me?
Yes, I can. How are you doing?
Pretty good. How about you?
Doing good, doing good. Did you
Yeah.
did you redo the homework?
Say that again.
The homework with uh systems of inequality.
Is that the draft you sent back?
Yep, yep,
Oh, okay. No, I have not done it yet.
yeah, pretty.
Was that just what were we supposed to do? That correct it?
Yep, make corrections and please turn that in. Good. You can
Okay.
send me a you can just basically you scan it and then send out the file. Good.
Yep.
Yeah, I want to make sure you guys are good with that. And so today we actually get into some new content is solving quadratic equations. And I'm recording this so you can watch it later. Good. Yeah, so
Yep.
yeah, so since you have come here, we're almost end of it, so those may not make sense to you. But I'll try to explain it, okay?
I got x as -3 and -2.
So x is -3 and or x is -2. That's what you got.
Yeah.
Okay, let's see. One thing you can check is plug in and see if that's the case. So you can see that if it's -3 -3 squared plus 5 -3 plus 2. Now -3 times a square is 9, so 3 times 9 minus 15 plus 2. This is 27. So 27 minus 15 plus 2. This gives us 12 plus 12, 2, that's 14. So that's not 0. So we know this is not the solution. Good. Okay. So now let's see why is that. Well, we said that we have to break the 3. So the only way we can break 3 is basically the factor of 3 is 1 and 3. And we can also break this into 1 or 2. Now, if you do that, you can see that 1 times 2 is 2. 3 times 1 is 3. 3 plus 2 is 5. So we know we can break it. So now we can write this as x plus 1 and 3x plus 2. And so Matthew, basically, we're going to break this into 2 factors, x plus 1, 3x plus 2. And we know that's equal to 0. So now, based on the 0 product property, if we got 2 numbers multiplied to 0, then we could have either this is 0. If this is 0, we don't care about this. 0 times anything is 0. Or we could have this is 0, then we don't care about this side. Same thing, 0 times anything is 0. So based on that, we could have x plus 1 equal to 0. That gave us x equal to -1, or 3x plus 2 equal to 0. Then 3x equal to -2. Then x is -2/3. So that's how we got those, either this or that. Good, Addie?
Yeah.
Okay, let's try 2x squared plus 3x and minus 5 equal to 0. Let's see how you got this one.
I got x equals -1 and x equals 5.
X equal to -1 and x equal to 5, right?
Yeah.
Same thing, we can plug in. If we plug in x equal to -1, what we say here is 2, -1 squared minus 3 minus 5. Well, that is 2 minus 3 minus 5. So that doesn't work. So it cannot be -1. Or we can plug in x equal to 5 and see what we got. We got 2, 5 squared plus 3 and 5 and minus 5. So what I got here is 2 times 25, and this is 15. Well, 15 minus 5 is 20 already, and this is positive, so it's not there. So we know neither are not good. So let's see why. Why is that case? Well, what we're going to do is, first of all, we break 2 into 1 times 2. So 1 times 2. Now the other one has to be either -5, 1. Now, in this case, 1 times 1 is 1. This is -10. Add together -9. So that won't work. So the other way we can do is plug in this one to this side, and this is here. So if we do that, we got -5. Then we got 2, which gave us -3. But we need to have +3. So therefore, we can change this into -1 here, 5 here. So we still, 1 times 2 is 2. That's good. -1 times 5 is -5. That's good too. Then we multiply that, cross multiply. 1 times 5 is 5. 2 times -1 is -2. Add together 3. So that works. All right. And now we can break into this as x minus 1 and 2x plus 5. And so we know this has to be 0. What we got is x minus 1 equal to 0. That gives us x equal to 1. Or 2x plus 5 is 0. And that gives us 2x equal to -5. Then x is -5 to the second part. -5/2. Yep, we good on this one?
Yeah. I forgot to do the 2x plus 5. I just did x plus 5.
Okay, right. You need to get that 2x plus 5. Good?
Yeah. Yeah.
Okay, let's try one more. 2x squared. So minus, say, 5x and plus 2 equal to 0.
So does the equation always has to be 0?
Yeah. If it's not 0, you can always make that into this situation. The reason for that is because we have to make into this equal to 0, right?
Yeah.
So then we can use the zero product property to break it. If this side is not 0, say it's 3, then we cannot do it. Good?
Yeah.
So that's why, I mean, sometimes you got a equation, like say you could have 4x plus 1 equals to x squared, then we have to basically move this over to that side, then x squared minus 4x minus 1 equal to 0. So we have to write it in such a this form. Good?
Yeah.
Yeah, this is something we call the standard form for quadratic equation. We write as ax squared plus bx plus c equal to 0. So this is kind of our format or our template. We got x squared term because we're dealing with quadratic equation. Then we have a coefficient, constant, have another constant in front x, and we have another constant here. Right, so this is the form we call the standard form. Good.
Yeah.
Okay, let's see if we can do this one.
I got x equals 4 and x equals 1/2.
X equals to 4 and x equals to 1/2.
Yeah.
Okay, let's see how we break it. We can, of course, this could be 2, 1. Now, if we use 1, 2, then we can see that this times that is 4, this time that is 1. 1 plus 4 is 5, but we're negative 5, and that's easy to change. Just make that -1, -2. So we got 2x minus 1, then x minus 2 equal to 0, right? We good on this?
Yeah, instead of the -2, I accidentally wrote -4.
Right. So now we got 2x minus 1 is equal to 0, then x will be half, or x minus 2 equals 0, then x equal to 2. So that were our two solutions. And we can actually checking it by plugging in. And that is, to make sure we got right, we was going to verify it. So 2 squared minus 5 times 2 plus 2. It should be 0 if this is a solution. So this is 2 times 4, and this is 10 plus 2, and that's 8 minus 10 plus 2. That's indeed 0. So we check the x equal 2 is a solution, and we can also check x equal half, and we got 2 half squared minus 5 times half plus 2. We got 2. This is 1/4. This is we know 5/2 plus 2. That give us half minus 5/2 plus 2. Then half plus minus 2/5. That give us -4/2 plus 2. And this -4/2 is -2 plus 2. That's indeed 0. So that way we check both solutions are correct, are the solution for this equation. Yep. Pretty good.
Yeah.
Very good. Okay, so that's what we have. Okay. I'll see you next week, and this week I'll give you the Q3 test. Okay, so I'll put on both the class dojo and the think way, and also I'll email that to your parents. Good?
Yeah.
All right.
Yep. Thank you.
Okay.
Thank you.
See you next week.
See you next week. Bye.
All right.